students, we were discussing solutions, and in solutions we discussed different types of solutions depending upon solute and solvent. Next we discussed various concentration terms for solutions. Then we discussed Raoult's law and Henry's law. From Raoult's law we got that there are in Raoult's law there are two cases. One when both the components are volatile, and second when one of the component is non-volatile. And on the basis of Raoult's law we discussed two types of solutions: ideal solutions and non-ideal solutions. Ideal solutions are the solutions which obey Raoult's law, and non-ideal solutions which do not obey Raoult's law. Now what is Raoult's law? Raoult's law says that partial pressure of a component is always equal to product of its mole fraction and its vapor pressure in its pure state. Any liquid mixture, any solution which follows Raoult's law is called ideal solution. And in practice, ideal solutions do not exist. However, for a very dilute solution, we can consider them ideal solutions, because very dilute solutions, they will behave like ideal solutions. In case of ideal solutions, delta V mixing is always 0, means when you mix solute with solvent, there is no change in volume. The net, there is the volume, if we are adding 5 ml to 10 ml, the expected volume is 15 ml and we get 15 ml. And delta H mixing is also 0, means when solute is mixed with solvent, neither the heat is absorbed nor the heat is evolved. ना तो heat absorb होगी ना evolve होगी. Neither the solution is cooled down nor it is heated up. And the interaction between solute particles and interaction between solvent particles is equal to the interaction between solute and solvent particles. If we draw a graph taking mole fraction on the x-axis and vapor pressure on the y-axis, we get a straight line over here where the pressure of the solution can be given as sum of partial pressure of both the components. And partial pressure we can calculate with the help of Raoult's law. With the help of Raoult's law, which states that partial pressure of the component is always equal to product of the mole fraction and its pressure in the pure state. Here we have taken mole fraction of A and mole fraction of B. We know that sum total of mole fraction of both the components is always equal to 1. So if we say that in this direction mole fraction of A is decreasing, automatically B is increasing. If A is decreasing, B is increasing. Right? So we have examples for ideal solutions like N-hexane, N-heptane. When you mix N-hexane with N-heptane, the solution becomes ideal solution, means it obeys Raoult's law. Similarly, we have solution of ethyl bromide and ethyl chloride. They also behave like ideal solution. Chlorobenzene and bromobenzene, they also behave like ideal solutions. Ideal solutions की खास बात क्या है कि ideal solution के जो solute and solvent हैं, उनको हम with the help of distillation we can separate them. Do you know what is distillation? In distillation, what we do, we take the solution in a round bottom flask and a condenser is fitted to it. The solution is heated and it's at its boiling point, all the fractions they boiling, and we can separate them at different temperatures. Temperature according to their boiling point. Means if we do the distillation of N-hexane and N-heptane, N-hexane will boil at its boiling point, heptane will be left, and then heptane will be boiled at its boiling point. That type of phenomena is called distillation. Distillation is evaporation followed by condensation. Means आपने पहले solute और solvent को evaporate किया, फिर condense करके वापस उनको liquid में convert कर लिया. So ideal solution की खास बात क्या है? Ideal components of ideal solution can be separated with the help of distillation. Distillation में if you might have seen in your laboratories, थोड़ा सा diagrammatically I tell you. This is the round bottom flask. इसमें हमने अपना mixture ले लिया, and this is fitted with a kind of distillation set. This distillation set has got an inlet and outlet for water, where the water gets circulated so that the vapors coming to this, they get condensed, and here we can collect the component. Once you start boiling this mixture, when you boil off this mixture, let us say component A, vapors of component A will go to this distillation set, and water is being circulated. So ये जो vapors हैं they get condensed, ये ठंडे हो जाएंगे और यहाँ पे आके collect हो जाएंगे at the boiling point of A. पहले हम A को separate कर लेंगे and the left part is B, और अगर आप चाहो तो B को भी evaporate करके condense करके we can separate it, and that phenomena is called distillation. So ideal solutions की खास बात क्या है? In case of ideal solutions, both the components can be separated with the help of distillation. Then we have non-ideal solutions. Non-ideal solutions are the solutions which do not obey Raoult's law. They do not obey Raoult's law and deviate in two ways. They show two types of deviation. One are the solutions showing positive deviation, and the other are the solutions showing negative deviation. First of all, we discuss the solutions showing positive deviation. Positive deviation solutions, in that case when solute is mixed with solvent, delta H mixing is positive. Delta H mixing positive means heat is absorbed. When you mix solute with solvent, some amount of heat is absorbed from the surroundings, then delta V mixing is positive. And delta V mixing is also positive. Delta V mixing positive means the volume is increased as compared to the expected volume. Although the increase is not much, it is also always a partial change in volume, but still there is some increase in volume. And if we talk about the interactions, the solute-solute interaction, solvent-solvent interaction is more than solute-solvent interaction. And if we plot the graph of vapor pressure with respect to mole fraction, this was the expected straight line. But what we observe from the graph, that the expected vapor pressure is more. The partial vapor pressure is more than the expected vapor pressure for both the components. So as a result, vapor pressure of the solution is also more than the expected. Right? If we take the examples, we have acetone and carbon disulfide, acetone and ethyl alcohol or ethanol, acetone with benzene, ethanol with water, methanol with water, chloroform with ethanol. They all form solutions, but these solutions are not ideal solutions. they do not obey Rolle's law. They show positive deviation from their ideal behavior. Positive deviation means their pressure would be more, vapor pressure would be more than the expected vapor pressure. Delta H mixing would be positive, delta V mixing will also be positive. Now these non-ideal solutions which show positive deviation, they cannot be separated by distillation. Sometimes we get a question, distinguish ideal and non-ideal solution. So to differentiate ideal from non-ideal, this is also a point that in ideal solution we can separate both the components with the help of distillation, but in case of non-ideal solutions, they cannot be separated with the help of distillation. They cannot be separated because after a certain composition, at a certain composition, they start boiling at a constant composition. Means, I tell you, let us say we have a mixture of acetone and carbon disulfide and we start distilling them. A time will come when the carbon disulfide left in the solution is 67%. Whatever you have taken, out of that 67% carbon dioxide is left. Now this acetone and carbon disulfide mixture do not get separated. They are not separated. Whenever you boil them, they will boil, but the mixture you are getting, the content you are getting in your flask will always contain carbon dioxide and carbon disulfide and acetone in this composition, where carbon disulfide will always be 67%. Similarly, let us say we are preparing ethanol. Ethanol you can never get 100% pure. Whenever it comes to 95%, it starts making it starts boiling at a constant composition with water. At a constant composition means, now if you boil off the mixture, the mixture you are getting in the flask will always contain 95% ethanol and 5% water. Means you cannot separate water from ethanol with the help of distillation. Now if you want to dry this ethanol, you have to use another method. You cannot separate water and alcohol with the help of distillation because they have made a constant boiling mixture. Constant boiling mixture means the mixture which boils off at a constant composition just like a pure liquid. Such mixtures are called azeotropes. Azeotropes, or they are called constant boiling mixtures. Solutions which show positive deviation are called minimum boiling azeotropes. Minimum boiling azeotropes. Next we have the non-ideal solutions showing negative deviation. Negative deviation means, first of all, do not obey Rolle's law. They don't obey Rolle's law. Delta H mixing is negative, means when you mix solute with solvent, some amount of heat is evolved. The mixing is exothermic, and delta V mixing is negative, means the total volume of the solution will be less than the expected volume. If you are mixing 5 with 10, you are not going to get 15, you are going to get less than 15. So the volume is less than the expected volume. And the interaction, solute-solute interaction, solvent-solvent interaction, that is less than solute-solvent interaction. If you plot it graphically, on the x-axis we take mole fraction, on the y-axis we take vapor pressure, and you can see from the graph that the expected pressure of the solution is less than the vapor pressure of the solution is less than the expected vapor pressure. जो हम सोचते थे कि ये वेपर प्रेशर आएगा, जो आता है that is always less than, right? So if we see the examples, we have water and HCl. You might have observed whenever we add acid to water, water to acid or acid to water, all of a sudden there is a large amount of heat evolved because the solution is non-ideal solution showing negative deviation. Then water with nitric acid, water with hydrogen iodide, water with HClO4. Just like the solutions showing positive deviation, they cannot be separated by distillation. Similarly, solutions showing negative deviation cannot be separated by distillation because they also make azeotropes. What are azeotropes? Azeotropes are constant boiling mixture, the mixture which boils at a constant composition. For example, in this case, water and HCl, they make a azeotrope at a composition when HCl is 20%. Water and nitric acid, they form azeotrope when nitric acid is 68%. Even in lab, if you see the bottle of nitric acid, it is often written over there 68% nitric acid. Means in that bottle, if we take 100 ml of nitric acid, 68% is nitric acid and rest of that is water. Similarly, with HClO4, the azeotrope is formed at a composition of 71.6%. Now, if you boil this mixture, you are not going to get separate water and separate HClO4. What you will get? You will always get a mixture at a composition of 71.6% HClO4. Such solutions are called azeotropes, and solutions with negative deviation, they form maximum boiling azeotropes. So now we come to the term that ideal solutions do not form azeotropes, but non-ideal solutions, they form azeotropes. Solutions which show positive deviation, they form minimum boiling azeotropes, and solutions which show negative deviation, they form maximum boiling azeotropes. And such mixture, which are azeotropic mixture, can be defined as: azeotropic mixture is a type of liquid mixture having definite composition and boiling like a pure liquid. Like a pure liquid means if you are boiling the mixture of nitric acid and water, it will not boil like a mixture. It will not boil like a liquid, because liquid has a particular boiling point. They boil at their own boiling point. But now it is a mixture. So the mixture is boiling at a different boiling point, different from its original components. So such mixtures are called azeotropic mixtures. They are formed from non-ideal solutions. Azeotropic mixtures cannot be separated by distillation. They cannot be separated. So this is about ideal and non-ideal solutions. You can write it down, you can plot the graph. Whenever you have a question, let us say if you have a question related to ideal, non-ideal solutions, you have to write all these points where you have to mention delta V mixing, delta H mixing, interactions, diagram, examples. Do they form azeotropes or not? If they form azeotropes, what type of azeotropes do they form? So you have to write all the points, right? So this is about ideal and non-ideal solution. The next topic we have is a new topic, colligative properties. This is a new term for you in your 12th standard, colligative properties. What are colligative properties? Now again, going back to, I told you when we were doing relative lowering in vapor pressure that this will come again and again in the chapter. If you remember, what is relative lowering in vapor pressure? What did we do in that? We simply added a non-volatile solute to solvent, and we observe that vapor pressure of solvent is decreased when it goes in the solution. And this lowering in vapor pressure we calculated with this expression, where we found that relative lowering in vapor pressure is always equal to mole fraction of solute. Mole fraction of solute means it depends upon number of moles of solute added. हमने कहा था जितना solute ज़्यादा होगा उतनी lowering in vapor pressure हो जाएगी. तो इसका मतलब क्या है? जो lowering in vapor pressure है, relative lowering in vapor pressure है, वो किस बात पे डिपेंड कर रही है? That depends upon number of moles of solute. वो इस बात पर डिपेंड नहीं कर रही that which solute have you added. Have you added NaCl? Have you added sugar? Have you added any other non-volatile solute? Does it matter? It does not matter. Vapor pressure of water will decrease. Although the decrease may be different in different kind of solute, but it will definitely decrease. So it is decreasing depending upon what? It does not depend upon nature of solute, but it depends upon number of moles of solute. So such properties of a solution which depend upon amount of solute and do not depend upon nature of solute are called colligative properties. So what are colligative properties? The properties of a solution which depends upon number of particles, which depends upon number of solute particles. They are called colligative properties, and we have 4 colligative properties of a solution that we will discuss one by one. Do you understand what is colligative property? Colligative property is the property of a solution. किसी भी solution की वो property जो इस बात पे निर्भर करे कि कितने solute particles हमने डाले हैं. How many solute particles are there in the solution? Then the property is called colligative property. We have 4 colligative properties. The first is ये जो हमने discuss की, relative lowering in vapor pressure. कई बार ऑब्जेक्टिव्स में क्वेश्चन आ जाता है which of the following is a colligative property और which of the following is not a colligative property. अब देखो, अगर हम बात करें वेपर प्रेशर, क्या वेपर प्रेशर एक colligative property है? क्या वेपर प्रेशर इस बात पे डिपेंड करता है कि कितने सोल्यूट हैं कितने? Vapor pressure is not a colligative property. Relative lowering in vapor pressure is a colligative property. Second, we have elevation in boiling point. Third, we have depression in freezing point. And the fourth, we have osmotic pressure. So we have 4 colligative properties: relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. यहाँ पे we have to keep in mind relative lowering in vapor pressure is a colligative property, not the vapor pressure. Similarly, elevation in boiling point. Elevation in boiling point का मतलब है boiling point का बढ़ जाना. If water is boiling at 100 degree, let us say, water का boiling point 100 है, it will be more than 100. Then that will be called elevation in boiling point. Similarly, boiling point is not a colligative property. Elevation in boiling point is a colligative property. Depression in freezing point. Freezing point is not a colligative property. Depression in freezing point is a colligative property. And the fourth is osmotic pressure. Osmotic pressure we get from osmosis. Osmosis term, do you know what is osmosis? We'll discuss it later. Osmosis is not a colligative property, but osmotic pressure is a colligative property. And what is colligative property? The property which depend upon number of solute particles. Means all these four properties, they depend upon how many number of solute particles have been added to the solution. We have four colligative properties which depend upon number of solute particles, and these are relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure.